You hear the term machine learning thrown around all the time, right? But what does it actually mean for a machine to think? Well, today we're going to pull back the curtain and break down how this incredible technology really works. I know, it sounds like something straight out of a sci-fi movie, but honestly, the main idea is way more straightforward than you might think. We're not talking about robots becoming self-aware or anything like that. Nope, it's really just about a totally different way of telling computers what to do. Okay, so think about it like this. With old school programming, you have to write out every single rule by hand. It's like, if you see this, then do that. Super specific, super rigid. But with machine learning, we flip the script. We don't give it the rules. Instead, we just dump a whole bunch of examples, a ton of data, at it, and say, here, you figure out the patterns. And that right there, that's a total game changer. And that brings us right into our first big idea here. We're talking about a whole new kind of learning. It's actually a lot more like how we learn, Not by memorizing a giant instruction manual for life, but by just living it, by gaining wisdom from experience. So here's the core concept. Machine learning is what lets a computer sift through, say, 1 million pictures of cats. And from all those pictures, it learns what a cat is. No programmer had to write a rule like, okay, if it has pointy ears and whiskers and a fluffy tail, it's a cat. The machine just gets the vibe of cat straight from the data. It learns the concept itself. Okay, so you might be thinking, why bother with all this? Why not just stick to the old way? Well, the simple answer is, some problems are just way too messy, too complex to ever be solved with a simple list of rules. Just imagine trying to write a program to recognize your friend's voice in a super loud, crowded cafe. Could you actually write down the rules for that? The exact pitch, the way they pause, all the little inflections. It's basically impossible, right? And that is exactly where machine learning comes in. It lives for those messy gray areas where simple rules just fall apart. And this is why ML is such a big deal in the real world. We're talking about everything from helping doctors spot diseases in scans to just, keeping spam out of your inbox. It takes on jobs that are way too complicated or just plain enormous for any person to do well. But here's the really cool part. These systems aren't static. They actually get smarter. The more data you feed them, the better they get at their job. All right, so how does a machine actually do this studying? Let's stick with an analogy. You can think of the entire process like a student getting ready for a final exam. There's a clear process. You get the material, you study it, you get feedback, and then you take the test. First, you need the textbooks. That's your data. Then comes the training phase. This is like the all-night cram session where the model is just digging through everything, trying to find patterns. The feedback loop is absolutely key. It's like doing practice problems, checking your answers, and figuring out where you went wrong. And finally, you have the evaluation. That's the big exam. You give the model brand new problems it's never seen before. This is to make sure it actually learned the material and didn't just memorize the answers from the textbook. And listen, if there's one thing you take away from this, let it be this. Data is everything. I mean it. You can have the fanciest, most powerful algorithm in the world, but if your data, your textbooks, is garbage, if it's biased or incomplete or just wrong, then the machine is going to learn all the wrong lessons. It's the classic saying, garbage in, garbage out. It couldn't be more true here. Okay, so just like some of us are visual learners and others learn by doing, machines also have different learning styles. We can basically break them down into 3 main categories. First up, we have what's called supervised learning. The best way to think about this is learning with a teacher. The machine gets a bunch of problems, but it also gets the answer key. The data is all nicely labeled with the correct answers. Its whole job is just to figure out the connection between the question and the right answer. So check this out. Imagine we feed the machine a ton of patient data. Each person's file is clearly marked sick or healthy. After looking at thousands and thousands of these labeled examples, it starts to pick up on the patterns. That way, when a new patient comes along without a label, the machine can make a really educated guess about their health. All right, next up is unsupervised learning. Now this is totally different. Imagine someone drops you in a massive library where none of the books have titles or are sorted in any way, and your job is to make sense of it all. That's what this is like. The machine gets a huge pile of data with 0 labels, and it has to find the hidden patterns and structures all by itself. So, look here. We've got the same kind of patient data as before, but notice what's gone. That label column, there's no answer key. So what does the machine do? Well, it might start to notice natural groups or clusters.
Maybe it groups patients together by age ranges or finds some other connection we didn't even think to look for. It's not looking for sick or healthy. It's just finding what's similar. It's all about discovering that hidden structure.
And last but not least, there's reinforcement learning. This one is all about learning by doing. The perfect analogy is training a dog. You don't give the dog a rule book, you say sit, and when it sits, it gets a treat, a reward. If it does something wrong, maybe it gets a stern no, a penalty. That's exactly how this works. An algorithm, called an agent, just tries stuff out in an environment. Good actions get rewarded, bad ones get penalized. It learns the best way to do things through pure trial and error. So it's this constant cycle of action and consequence. The system tries something, like, I think that's a mango, and it gets feedback, nope, that's an apple, no reward for you. Then it tries again, over and over, through this loop. It slowly figures out the strategy that gets it the most rewards. And this simple idea, it's the powerhouse behind everything, from AIs that can beat grandmasters at chess to the robots you see in advanced manufacturing.
Okay, so we've got the basic mechanics down, but let's zoom out. What does all this actually mean for us, for society? Because this technology is incredibly powerful, but it also comes with some pretty serious pitfalls that we absolutely have to talk about. On the plus side, the benefits are just massive. I'm talking about automating all the boring, repetitive stuff, discovering insights from data that would be impossible for a human to find, and getting those super personalized experiences, like a perfectly curated playlist. The potential to make our lives easier and more productive is just huge. But, and this is a big but, we have to be careful, really careful, because if the data we feed these machines is biased, and a lot of our historical data is, the AI will learn those biases, and it might even make them worse. That can lead to seriously unfair decisions. Then you've got the huge privacy risks that come with collecting all this data. And maybe one of the biggest issues is the black box problem. A lot of the time these models work, but we have no idea how. We can't see their reasoning. And how can you trust a decision if you can't understand it? Oh, and of course, we can't ignore the impact this will have on jobs. The thing is, this isn't science fiction anymore. Machine learning isn't some coming soon tech. It's already here. It's woven into the fabric of our daily lives. It's the thing that helps your bank flag a weird transaction. It's what helps doctors spot cancer earlier. And yep, it's the reason Netflix is so creepily good at knowing exactly what movie you want to watch next. It's happening all around us right now.
And that leaves us with a pretty deep thought to end on. Remember, these machines learn from our data, our decisions, our history, our biases. So in a way, they're becoming a mirror. They reflect our world back at us. And the big question is, as that mirror gets clearer and clearer, what patterns is it going to show us about ourselves?